Now we have to consider a circle inscribed in an equilateral triangle of length x, and the part F says show that like PCN represents the perimeter of n-sided regular polygon circumscribed about a circle of radius 1 unit. And we have to show that the perimeter of n-sided polygon is given by 2n tan pi by n. So for this we'll consider the triangle here. So we know that the angle of this triangle, angle at center, should be 2 pi over n, since it's the n-sided polygon and the base is x unit. So we divide this triangle into a right angle now. So the angle is going to be pi over n, and obviously this is radius 1 here, so it's 1, and the length opposite to it is half x. So we can simply use opposite over adjacent, which is tan pi over n is opposite half x over adjacent is 1. So x, you can get x equals to 2 times of tan pi over n. So perimeter of the n-sided polygon should be n times of this value of x, so it's 2n tan pi over n. This is the perimeter of n-sided polygon, which is circumscribed about a circle of radius 1. Now the next part, they said consider the function px equals to 2x tan pi by x, where x belongs to real number and x greater than 2. So part G1, they said by writing px in the form of this particular fraction, you have to find the limit. So if we write the function here, which is p of x equals to 2x tan pi over x, if we take this x to the denominator, we can write this as 2 tan pi over x over 1 over x. So if we apply the limit now, limit x tends to infinity, so we'll get infinity over infinity. Let me write it. Limit x tends to infinity of px is going to be infinity over infinity. In fact, it is 0 over 0, because pi over infinity is tan 0 and tan 0 is 0, over when we apply the infinity to the denominator, that will be 1 over infinity, which is 0. So 0 over 0. So L'Hopital rule is applicable. So for L'Hopital rule, we have to differentiate both the numerator and denominator. So we can apply the L'Hopital rule then. So when we differentiate the numerator, we get 2 times of sec square pi over x and the derivative of pi over x over the derivative of 1 over x is going to be minus 1 over x square, and subsequently it will be 2 sec square x, and this derivative also is minus pi over x square over minus 1 over x square. So it is 2 sec square pi over x, and the x square is cancelled, so it's just pi also, so we'll write 2 pi here. We'll write 2 pi. Now we can apply the limit, so that will be limit x tends to infinity 2 pi sec square pi over infinity here, that makes it 0. So it's 2 pi sec square of 0. So sec square of 0, we can find the 1 over cos. So cos 0 is 1. So sec square is also 1. So that gives you the value of 2 pi then. So the limit x tends to infinity of p of x, let me just correct it, p of x is equals to 2 pi. That's what the limit is.